Okay, let's try to skip. Morning!
Morning.
Yay! There we go. Okay, so that's why I didn't want to work, because we didn't start with morning. All right, definite integrals, this is important, blah, blah, blah. Okay, so a indefinite integral, I have plus c. A definite integral has bounds, top minus bottom, right?
Yes.
Okay, we just went over that. Okay, so these things are super important here. It is kind of grainy. I don't know why, because when I was copying it, the picture didn't come out very well. On yours, it's similar. If you guys find it in the textbook, they're also in some of those cards that I gave you guys too, the flashcards. Okay, some of them, this one is not used very often. So that's x to the a. Actually, no, that one, where a, no, it's a to the x. Sorry, not that one. It's this one right here. This one is standard. That's the one that we've been doing all this time. I know, I'm trying, yeah, it's all grainy, so I'm like, no, yeah, a to the x. A to the x, that's the one that's not used very often. So that one's not used very often. Okay, my trig, the trig integration. Okay, and where are we at for the next one? Arc sine, arc cosine. And these things right here, those are hyperbolic. Okay, with cosine 8 or sine hx. So hyperbolic, we don't get into those. That one we touched in BC, but not here. Okay, so now indefinite integrals. Okay, so let's go ahead and do this. So it should be pretty easy here because I've been having you guys do this over and over again. So for this one right here, for a, that's going to do my exponent first, right? So it's going to be x to the over. So it's going to be x to the 5th over 5. And what can I not forget? Plus c, right? There we go. Now, for b, that one's a good one. Okay, what's my exponent on b? 1/2. So I need to add 2 over 2. I need to add 2 over 2, don't I? So that's going to give me, first we're doing our exponent, right? So it's going to be x to the 3/2. And I'm dividing by 3/2, so but it's the same as multiplying by 2/3. So it's going to be a 2/3. And what can I not forget? There we go. Okay, now this one, sine divided by cosine squared. So, now, I'm going to do some trig sub on this first. Alright, so now, what is sine over cosine? Oh, really? Really? Bro, chew your food! Wah, 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 wah. That's all I heard. Okay, so we're going to do sine over cosine gives me tangent, right? So I'm going to have tangent. So if I rewrite this, it's going to be tangent x times, now, because I'm rewriting this, that's going to leave one cosine on the bottom, right? Yeah, so if it's 1 over cosine, now it's going to be secant. So I was able to rewrite it. So now tangent secant. Okay, so if I go back right here, secant tangent or tangent secant is going to give me right here. Now, remember those derivative rules I kept telling you guys you got to memorize. So the derivative of secant is secant tangent, right? So the antiderivative of secant tangent is, there we go. That's all we're doing. So that means this one's going to equal, okay, it's going to be secant of x plus c. Not bad, right? Okay. Properties of indefinite integral. Since the definite integral and the indefinite integral are closely related, properties of indefinite integrals are very similar to those of definite integrals. Yeah? So, derivative of an indefinite integral. Okay, so same thing that we have been doing, right? The fundamental theory of calculus part 1. Property 1 is consequence of a definite integral right here for an example. So we take this, we get this. No. There we go. Line it back up. Okay. So from here, we can go back and forth. Integration and derivatives. Okay, same thing we can. Okay, break them up. Same thing that we have been doing. There's my constant multiple, k value, multiplying a coefficient. So I could factor it out and just multiply back in. We've done that. Okay. Properties of that. So I could actually use the property to break it up into two separate. So it would be the same as saying the integration of 2x to 1/3 dx plus the integration of 5x to -1 dx. So I could separate it as needed. Sometimes you don't need to separate it. Sometimes you want to put them together to make it easier. But still. All right, so when I'm adding a constant to my first one and the second one, so I'm adding some number, and then I'm adding another number. But then at the end, when I put the sum number and another number together, I get my C value. Because I'm getting two numbers together from both of these, and they're both going to just end up becoming my C value. I don't know what this one is, I don't know what this one is, but together they give me C. So when I do this, I'm going to get, it's going to look like this. So when I do this right here, I'm adding 3/3, right? So it's x to the 4/3. Yes? Okay, but there's a 2 out front, right? Say yes. There's a 2 out front, and I'm going to multiply by 3/4, right? I'm multiplying by 3/4. But there's still a 2 out front. 3 what? Very good. Plus C, right? No, I'm going to call this one C1 because it's something from over here. And you'll see the reason for it here in a minute. All right, now this one right here. Is it 1/x? Is it 5 times 1/x? Say yes. Because that x to -1 is the same as saying 1/x, isn't it? If I add 1 to that -1, what do you get? 0. Okay, that's going to be x to 0. So that's actually going to mess up everything, isn't it? So that does not work out. That's why when we have 1/x, there we go, there's my ln, right? So I'm going to have my ln here on this one, because if I add 1, I get x to 0. Okay, so the rule applies here that when I have this, it's going to give me ln, right, of x. But is there a k value here? There is a value in front of it. It's a constant multiplier, right? So it's just going to be 5 times that value. So it's going to be 5 ln of x plus my c from the second one. Yes?
Doesn't have to be absolute value.
Yes, it Thank you. Man, good job. Okay, good job on that one. Why does it have to be absolute value? Is there restrictions on ln? X can't be negative, can it? If you think of the graph of ln, it looks like this. Right? So it doesn't exist for negative, right? So since this one right here does not have bounds that we're plugging in, so it has a restriction there. And we're showing an absolute value to show that restriction, because whenever I take the ln of a indefinite integral, I need to show that there's an absolute value. On my definite integral, I did it a little bit, but when I plug in the numbers, it went away anyway. For it to be continuous over that interval, yeah, it has to actually exist. But for this one, whatever numbers eventually might plug in, maybe. But for this, for my answer, I have absolute value. All right, so now, here's my something, and here's my other something, my C1 and C2. So you have something there, something over there, and together, it's just another something, isn't it? So when I put these two answers together, it's just one something. So it's just one C value. So even though I have two of these, it's something and something gives me another something. So my answer, 3. Just C. That's all I got to do. So yes, I have a C1 here and a C2 because a C from the first part, a C from the second part, but together, whatever something they are, it's something and something gives me something. Okay? Good. Okay, so for this right here, use these properties, same thing. I think this is the last one I do, but we'll see. All right, for this one right here, I could break it up, or I could just do it as is, right? I could break it up into two separate parts and have something and something, but 12 over x to the fifth. To do my integration, that x needs to go up, right? So that's going to be x to the negative fifth. So my integration is going to give me x to the negative 4, right? X to the negative 4, right? And so it's going to be over negative 4, isn't it? Negative 4, over negative 4. But there's a 12 out front of that, isn't there? Yeah. So that's going to be a 12 over negative 4. Yeah? And that's going to reduce. That's going to reduce. So, okay, so I'm going to put the x back down here in a minute, but I'm just showing where everything's going. Now, how about the bottom here? On the next part, what are we going to have? X to the negative 1/2, right? Because it's on the bottom, isn't it? If it's on the bottom, it's got to come up. And this is a 1/2 on the bottom, so it makes it a negative 1/2. And I'm going to add an exponent, aren't I? So it's going to be x to the, if it starts off at negative 1/2, becomes positive 1/2. Positive 1/2, right? And then I divide by 1/2, which would be the same as multiply by 2. And there's my plus sign right there. And then I have my plus c. So what could I do to clean that up? My 12 over negative 4 and bring my x down. So that's going to be negative 3 over x to the 4th plus 2x to the 1/2 plus c. All right, now this next one I'm going to hold off until tomorrow, Friday. So you guys have enough stuff to work on because we're going to do a long division on this next one. Okay? So, like, share, and subscribe, hit that notification button, and don't let me forget we're picking up on B tomorrow.